Now we talk about the properties of Z transform. So before that I go to the properties of Z transform. So in Z, the Hz, as I discussing, if a system, Hz is a system, if you see the Hz is a system, Hz is a system. So system impulse response is look like this. When I said that, so this is a notation you have to remember. If xn is time domain signal, then xz is z domain signal. If hn is time domain signal, then capital Hz is z domain signal. So when I write z domain, it will be capital and it will be z. Z domain means complex domain. It is equivalent to frequency domain. Let us go to the properties of Z transform. What are the properties? So the linearity property. Z transform is a linear transform. That means if a signal is linear, if the system is linear, after Z transform also it becomes linear. ROC may change, but system will depend that the Z transform will be linear. So how do you do that? How do you prove it? Again superposition principle. So I can say A1 x1n and A2 b into x2n, two different signals. So if I took the Z transform, it will be A x1z plus B x2z. Or if I apply entire signal and then took the Z transform, the expression will be same. So that means Z transform support the superposition principle. So that's why the Z transform is linear. So linearity, the Z transform is linear. Okay. Now for the time scaling, time shifting or time scaling, time shifting. So as you aware that when I draw the system level, that implementation of discrete system, structure 1 or structure 2. So what you say that z to the power minus 1 means one sample delay and z to the power plus 1 means one sample advance. So time shifting, that means if x of n is shifted by time n0, where n0 is an integer. So that means suppose I have an x of n, if I shifted in this side or this side, if I shifted in this side, so this is x of 0. So I want to shift it to here, which is let us say 5. So this is nothing but a x of n minus 5. When I go this side, so this is x of 0, this side is negative. It's become, so again here in fifth sample is x of n plus 5 because I have shifted in this side. So n is positive when I shifted in this side, n is negative when I shifted in this side. Now I can prove it. X of n minus n0 is nothing but a z to the power minus n0 into x of z. You can prove it. How do I prove it? Again, I just take a slides. If I want to mathematically also, I can prove it, no problem. So now my signal is x of n minus n0. So I know x of z is nothing but a n equal to minus infinity to infinity x of n into n z to the power minus n. Now I said x of n is shifted, change it n minus n0. Understand? So now I put the equation here and I can change, I can prove that this is nothing but a x of z. So if I shifted in this side, n0 is positive, then I can say x of z of this one will be n to the power minus n0 into x of z. If it is n is negative, this side, I can say n to the power plus n0 into z to the power plus n0 into x of z. So, when I shifted in this side, so what I said, if I shifted in this side, so suppose here is my x0, I want to shift it in 6th position, 6, x of 6. Here I want to make here, what is the meaning of, how do I represent x of 6? X of 6 is nothing but a n minus 6 into z to the power minus 6. So, when I transform it z domain, it becomes xz into z to the power minus 6. So, amplitude into z to the power minus 6, you know that. So, that is called shifting, time shifting. You can do this example also. This is my xz, and see, if I converted to the xn, it will be shifted by one sample, inverse transform. Or if I do the z transform of these things, it will come here. Okay. Then I said time reversal. Time reversal, that means if x of n is z transform if x of z, then x of minus n z transform will be x of z to the power minus 1. Time reversal. So, how do you prove it? Let us say I want to z transform x of minus n. It is nothing but n equal to infinity minus infinity to plus infinity x of minus n z to the power minus n. This is z transform. So, now if I say, let us say n minus n is equal to L, minus n is equal to L. So, I replace this minus n by L. So, when it is, I can say the L equal to minus infinity to plus infinity, x of L minus n represented by L, z to the power minus n is nothing but a L. So, if I want to make it minus L, how do I do? Z to the power minus 1 into the minus L. So, minus 1 into minus L is nothing but a z to the power L. Now, if you see this form is a z transform of XL. So, I can say it is nothing but a x of z to the power minus 1. Now, if the region of convergence is R1 and R2, let us say R1, so both sides it is there. So, I said region of convergence is the R1, Z is greater than R1 and Z is less than R2. Now, then I can say let Z is replaced by Z to the power minus 1. So, if it is when the Z is greater than R1, when it is Z to the power minus 1, that means Z should be less than 1 by R1. Understand? If Z is replaced by Z to the power minus 1, now when Z is less than R2, when it is replaced by Z to the power minus 1, it will be greater than 1 by R2. So, I can say the region of convergence of this transform, this xz is nothing but a 1 by R2 greater than Z less than equal to 1 by R1. Okay? Then next is differentiation. Many times we will use it during Z transform. That n, what is the Z transform of n of xn? It is nothing but a minus z into dxz by dz. Okay or not? So, if I do that, what is xz? Xz is equal to n equal to minus infinity to infinity x of n z to the power minus n. Now, if I want to find out what is dxz by dz, so I have to take the differentiation of this thing. So, it is this is okay, this is x of n. So, this first order difference is z to the power minus n into z to the power minus n minus 1. Now, let us say I said minus and minus z to the power minus 1 I take outside the summation. Then I said n equal to infinity infinity x n in, so n will be there and x of n will be there and z to the power minus n will be there. So, which is nothing but a z transform of n x of n. So, I can say the n x of n, the z transform of n x of n is equal to minus, I can say the 1 equal to this will be 1 by minus z to the power minus 1 dxz by dz, which is nothing but a minus z to the power minus z minus 1 will be go up to plus 1. So, minus z dxz by dz. So, z transform of n x n is nothing but a minus z and dxz by dz. Okay. So, many times we will use this formula for inverse transform or z transform. When you take a log 2z, let us say to log of xn plus 1. So, how do you do that z transform? So, use this differentiation method. Then scaling, very important issue, frequency scaling, time scaling. So, I can scale its amplitude and scale its frequency both. So, scaling. So, let us say a to the power n of xn. So, xn is my signal and scaling is done by a to the power n. So, a to the power n of xn. So, a to the power n is a scaling factor. So, what is z transform of a to the power n xn? So, I want to calculate the z transform of a to the power n x of n. Let us say x of n is un, let us say, or let us say xn, don't take un, let us say x of n. So, I can say a to the power n x of n z to the power minus n. So, I can say a can be divided by z. So, z by a to the power minus n, because a to the power n into z to the power minus n can be written as z by a whole to the power minus n, which is nothing but a z to the power minus n into divided by a to the power minus n, which is nothing but a z to the power minus n into a to the power n. So, that is why I written down a to the power n and z to the power minus n in the form of z by a to the power minus n. So, now you can see this one. This one is look like a z transform, while instead of z, I have a z by a. So, I can say it is nothing but a x of z by a. Okay. Now, a is a value. A can be a complex also. A can be real or A can be a complex also. Let us A is represented by R0 e to the power j omega 0, where I have written down. And what is Z? Z is nothing but Z is R e to the power j omega. Now, if I say what is the value of Z by A? So, Z by A is R e to the power j omega divided by R0 e to the power j omega 0. So, that is nothing but a R by R0 into e to the power j omega minus omega 0. Okay or not? So, I can say x of z by a, which is represented by a x omega, is nothing but a R by R0 e to the power j omega 0. Now, let us say R0 is equal to 1. So, if R0 is equal to 1, I can say that this scaling, this amplitude scaling is not there. So it is only rotating part is there. In Z domain it is rotating only. So shifting omega minus omega 0. Okay. So that is called scaling, Z transform scaling. Similarly, instead of a to the power n, I can scale it by e to the power j omega n, where r0 is, so it is nothing but e to the power j omega n into z. I can do multiply by cos omega n, I can multiply by sin omega n, so those are the z. Because here when I go for the cos omega n, here I can say z is nothing but a r e to the power j omega n. So in that case z is r cos omega n plus j sin omega n. Then I have an infinite series, then I do the Z transform. Okay. Similarly, another property is convolution. You have heard about time domain convolution, frequency domain multiplication. Z is like a frequency, but it is not frequency, it is Z domain. In Z domain also that valid. That means time domain convolution in Z domain is simple multiplication. Time domain convolution represented by a Z domain simple multiplication. You can prove it also. So let's say that x1 and x2, two signals are convolve each other. I want to find out what is x of z. So I take, let's say this is x of n, is x1 convolved with x2 n is my new x of n. So this is the z transform of x of n. Now I represent the convolution. So x1 k into x2 n minus k z to the power minus k. So this is my convolution term. X of n is a convolution which is nothing but a k equal to infinite to plus infinity, x1 k convolved with x2, that means n minus k. This is the convolution sum. So I represent the convolution sum in here. Now I can say, let's say this sum I written first and x1 k, and then this sum I written here, n minus n equal to minus infinity x2 n minus k z to the power minus n. What is there? It is nothing but a time shifting. N x of n minus n0 z to the power minus n0 x of z. So here n minus k is nothing but a x2z into z to the power minus k. So here I can say k equal to minus infinity to infinity x1 k into x2z into z to the power minus k. Now if I say x2z in here and I check the sum to here x1 k into z to the power minus k, this is nothing but a x1z. So it is nothing but a x of z is nothing but a x2z multiplied by x1z. So I can say time domain multiplication is not a time domain convolution is nothing but a multiplication in z domain, and region of convergence is nothing but a rx1 and rx2 their intersection of both signals, conversion of both signals. Okay. So suppose instead of doing convolution in time domain, I have an xn signal, I have an yn signal. Suppose I have given a two signal I have given, let's say instead of writing convolution, what we can do? Suppose I have a signal x1n is given, I have another signal x2n is given. So I can convert to x of x1z, I can take a z transform, I can convert to x2z. then I can create yz is equal to x1z multiplied by x2z. Then I get the inverse z transform, I get y of n. So, instead of computing y of n is equal to x1 n convolved with x2 n, I can take individual signal to z domain, multiply them and then take the inverse transform, I get y n. That also I can do instead of computing convolution. Okay. Next property is, okay, convolution, I have given an example, you can do that example. I will say that you will try to do it. x1 n is given, x2 n is given. Now you calculate x1 z, you calculate x2 z, then yz is this. Now you can calculate, you take the inverse transform, you can get yn. Okay. Similarly, z transform of correlation. So, convolution we have said. Now, it is a correlation. So, what is correlation? Let us say I have a signal x1 n and x2 n are two different signals. So, R of x1 x2 is the correlation between the x1 and x2, and this is the correlation equation. Now, you take the z transform, both sides you take the z transform. So, this becomes capital R x1 x2 z instead of L, because L is R x1 x2 L is also in discrete sequence. So, that becomes z domain, which is nothing but a x1 z multiplied by, instead of convolution it is x1 z multiplied by x2 z in correlation. Since I have not folded the signal, here it will be x1 z multiplied by x2 z to the power minus 1. Understand? So, that way I can calculate z transform correlation also I can calculate in z domain. Then there is another important theorem which is called initial value and final value theorem. Both ways, think about. Suppose, let us say it is an initial value, means initial value, suppose I have an xn, what is the initial value? Initial value is nothing but x of 0, is the initial value. So, what is initial theorem? Initial value theorem said that if I know xz, if I know the z domain representation of signal x of n, which is nothing but a xz, then if I take the limit z tends to infinite on that z domain signal, I get the initial value of the signal. So, what is initial value theorem said that for an unknown signal, if you know the z transform of that signal or z domain representation of the signal, then you can estimate that initial value of the signal. So, which is nothing but a x0. How do you do that? Now, x0 is equal to limit, put limit z tends to infinite on x of z, you get the initial value. What is the proof? So, I said limit z tends to infinite x of z. So, initial value theorem. So, z tends to infinite, what is x of z? N equal to 0 to infinity, x of n z to the power minus n. Now, you can break down the series. So, limit z tends to infinity, x of 0 plus x of 1 into z to the power minus 1 dot 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 to x to the x of infinite into z to the power minus infinity. Now, when I say put the z limit to infinite, so those portion become 0, only x0 is exist, which is nothing but x0. So, that is why I said initial value theorem said that if I know a z domain representation of a signal or system whatever, then if I put limit z tends to infinity of that z transform, I can estimate the initial value of the signal x0. This is the proof. Final value theorem, I can estimate the end value of the signal. How do you do that? End value is very simple. N tends to infinite. Here what I said, limit of x of n. End value. If the n is infinite, then n tends to infinite, which is equal to limit z tends to 1, z minus 1 into x of z. So, x of z will be multiplied by a z minus 1, then I put the limit z tends to 1, then I get the final value of the signal. If it is infinite, then x infinite. Let us say this is said that the example x of z is equal to this one. So, x of z I know x of z. So, what is the initial value and final value of this x of z signal xn, which is represented by z domain in x of z. So, for final value, what I have to do? Initial value, I have to say that limit z tends to infinite, and I have to evaluate this function limit only. And for final value, I have to multiply by z minus 1 into x of z, and then I have to limit for z equal to 1. Understand? So, what they do, they make a factorize, and then they multiply x of z minus 1 will be cancelled for that factorize, and then I put the z equal to 1 value, it is 5 by 0.5 is equal to 10. So, I can say final value is 10. Then what is the initial value? I can put z equal to infinite. So, I have to both sides I have to divide it by z to the z cube. Then I get, so it will be 3 by z minus 2 by z square plus 4 by z cube divided by, like that way you can do, and you evaluate the limit, you can get the initial value. So, those are the properties of Z transform. Next class, I will talk about the concept of pole and zero and why this Z transform is required to what kind of problem I can solve using Z transform. Why should I use Z transform? That I will discuss in the next class. Okay? Thank you.